Fantastic. Thank you all for joining. Looks like we're getting just a few more people from the waiting room, but that has slowed down. So thank you again for being here. I am so excited to be kicking off a brand new renewal season with you all. Last season, we talked about history and memory, how we learn from the past and learn not to repeat it. So this season, we are looking to the future, talking about what's down the road in a few years or maybe many, many years, and considering what that means for us and how we take actions to make the future better. So today we are starting off with the future of AI with our own Dr. Ted Vial. So I am so excited that you are here to be part of that. Just a couple of housekeeping notes before we dive in. This session is being recorded. You will receive a link to this recording in a couple of days along with a follow-up email so that you can go back and review our conversation here. If you would prefer not to be on that recording, that is absolutely fine. You'll just want to keep yourself muted and keep your camera off. Another note, even if you do want to be on the recording, please keep your camera muted while the
Yeah.
presenters are speaking. Inevitably, somebody's dog starts barking, so always helpful to head that off and have some, make sure we're all muted before we get into it. During the session, there will be some opportunities when you will get to come off of mute and ask questions. You can also ask those questions in the chat, and we will share them with the group. But please make sure that you're waiting for those opportunities to bring those questions forward and join in the conversation. I mentioned that you will receive the link to this recording after the session. That email will also have information about a survey. We would love to get your feedback. It's really important to make sure the topics we are bringing forward and the conversations we're having are the things our community's interested in and invested in. So your feedback is hugely helpful as we plan out this season, as we plan out other Iliff events. So thank you in advance. Your feedback is absolutely wonderful and a wonderful gift to us. Also in that email, there will be a link to register for next month's renewal because we are jumping into this full season with this first session. So there will be more information there as well. So keep an eye out, and I'll mention that again as we get to the end of our time together. But quite honestly, that's enough for me. So I am going to turn it over to the incredible Dr. Ted Vial himself.
Well, thanks, Kat. You're going to get this Ted Vial instead, but I thank you. And thanks for everybody for coming. And I am in the Iliff podcasting studio, which is what happens. I asked Amanda Henderson if I could borrow a microphone. And I feel like I'm on the deck of Star Trek Enterprise. So if anything goes haywire and you can't hear me, just let me know. I've been on the faculty at Iliff for 19 years, and I've been involved in one way or another with AI for 6 or 7 years. And I'll talk a little bit about why I care about it in the first place. But this is what I want to do in the next, 75 minutes. And I'll try to remember and feel free to put your hand up or break in at any point to ask me a question. But I'll try to remember to take a break after each section, so that I'm just going to cover a lot of ground pretty quickly. But I would love, any of you who have had me in class know that I'd rather talk with you and listen to you than lecture. All right, so I feel very fortunate to my field of expertise is 19th century German theology. So I never imagined that I would be here. It's just fortunate that I was at Iliff, and when I was the director of the Iliff DU Joint PhD program, we had an amazing student who also was an amazing staff member at Iliff, Justin Barber. Many of you will remember Justin. Whose dissertation was on Eusebius, and Eusebius died. He's old. He's died in 339 AD. He's known as the father of church history. He's a very erudite, one of the first historians to record early Christianity. And like all ancient scholars, he doesn't really have a system of citation. So it's one of the big problems in Eusebius studies, which I learned from Justin. It was not a problem in my life till I met Justin. Was that it's very difficult to know when Eusebius is quoting, when he's paraphrasing, when he's making stuff up, or when he's talking in his own voice. And so Justin was part of this group that Michael Hemingway also founded and Micah Saxton called the Digital Humanities Lab, which was intended to help faculty like me learn some of the new technology tools in our scholarship. Um, and so for his dissertation, Justin downloaded the entire Loeb's Greek classical library into a AI tool. So that has every known piece of Greek writing from the ancient world. And then he put the entire collection of Eusebius in there. And in about, I don't know, 2 days, was able to find every single reference, paraphrase, quote. This is a problem that's been bothering scholars for years. So that was a cool problem, although I don't actually care that much about Eusebius. But what was interesting to me was that I talked to Justin because his dissertation committee did not know how to evaluate his project because um, the criterion for getting a PhD is to make an original contribution to scholarship. And because Justin had taken open source code and modified it and used it for his project and then put it back out into the world, the dissertation committee was wondering what was Justin and what was other people and what was original about this. And so that struck me as a very interesting problem in theological anthropology, which is my constant, that's just the thing I always am interested in, is what is a human and what does it mean to be a human? And in this case, what does it mean to be an author and a scholar? Are you a single person sitting at a desk with a bunch of books? Are you somehow networked into a community? And aside from just conversations and citations, is the community somehow responsible for this thing that has your name on it? Um, and and so I was also happened to be working at the time on a 19th century Jewish woman who just published series of correspondence between her and her letter writing friends. And my belief is her name is Rahel von Hagen, that she has a theory of personhood, which is that there is no such thing as a single author. There just is a community that publishes together. At the time, I was chairing the publications committee of the American Academy of Religion. And so Alice Hunt asked me to start a task force on digital humanities to help institutions figure out how to evaluate the work of people who were applying for jobs or coming up for tenure. And then I was also on a task force for fostering cutting edge scholarship by younger scholars, because a lot of younger scholars are using digital humanities and a lot of the rest of us didn't know how to evaluate it. And so that kind of got me into AI in general. Okay. Then I started reading about it. And one of the first things I read was this book by a guy named Max Tegmark. He's a physicist at MIT. And he started something called, along with some other famous people like Elon Musk, the Future of Life Institute, which is concerned with steering technology in a way that will not lead to the apocalypse. So I have to assume that Max Tegmark is a super smart guy since he's a physicist at MIT. But the things he said about consciousness and intelligence just struck me as naive, and I'm trying hard not to say the word idiotic. That his dream is someday to take his entire consciousness, which he conceives as a bunch of information, and right now this information is running on what he thinks of as wetware in his brain, which his brain is the hardware, but there's no reason why you couldn't download that into a different substrate like a silicon chip, and be conscious forever. And in the world of theology and religious studies, for the past 30 years at least, it's been a major research initiative to show how human experience and intelligence and meaning making is an embodied experience. And I just almost couldn't believe that I was reading this book, this sort of famous book about AI. And then I realized, okay, I have a little bit of an inferiority complex. I took computer science in college. I took it because the professor was famous for being a good professor. I didn't really like it. I barely squeaked out of it with a passing grade. But when I read this book by Max Tegmark, I realized, okay, there's a real place for theologians and humanists to jump in here and have a conversation with folks who are more sort of algorithmically gifted. And then I started giving talks at churches and public spaces around Denver. And I was so, number one, I was so happy that usually when I give talks and my subject is 19th century German theology, I have to convince people that it's interesting before I start talking about it. But I didn't have to do that heavy lifting with AI. People just, they came, they were nervous, they were fascinated, they had a million questions. So it was very, very easy to talk about. And then I was very interested to discover that at the end of every talk, there seemed to be this incredible, almost neurotic drive towards human exceptionalism. That is, all the questions were about what makes humans different than AI. And it would always take some form of, yeah, okay, AI could do some cool stuff, but humans have creativity, or humans have emotion, or humans have consciousness, or humans have moral status, or humans have agency. And as somebody interested in what it means to be human and in theological anthropology, I realized this was a great opportunity to ask them, well, tell me what you think consciousness is, and then we can decide if machines can have it or not, or tell me why you think you have moral status, and then we'll decide if machines can have it or not. So this, it just opened up in a very kind of present and pressing way all of the questions that I find interesting to have public conversations about. And then the other thing I realized was that the two sort of goals in the West with AI, or the two fears or hopes, seems to be that AI will be our servants, and oftentimes the phrase slaves is used, or that that AI will someday enslave us. And I was struck by what that says about us, that our first reaction to this powerful technology is it's either going to be our servant or we're going to be its slaves. I think that says a lot about theological anthropology. All right, so I just want to talk a second about, I use the phrase artificial intelligence. I'm going to keep using it even though I don't like it. Not because it's not intelligent, but because I don't think it's artificial. I think it's a form of intelligence that's important in our world. And I just want to sort of open up the space. When we talk about artificial intelligence, we tend to talk about, playing chess or a certain kind of intelligence. But I just want to remind folks that when we talk about human intelligence, we have a lot of things in our mind, right? There is logical mathematical intelligence, but there's EQ, and there's visually intelligent people and linguistically intelligent people. So this is the famous sort of Howard Gardner theory of multiple intelligence, which has now been extended to like 9 kinds of intelligence. So I think it's very important to think about intelligence more broadly than, can this AI play a game of chess? And then we start thinking about all the forms of intelligence in the world, which is everywhere, right? So this is a picture of bees. And we all have heard the story of honeybees that find honey, come back to the hive, and can indicate where it is by dancing. But I've also learned that bees collaborate on where to relocate their hive when it's time to relocate. And this is sort of this is not just a signaling like, hey, the honey's over there. This is a very complex political decision-making process. So what happens is the hive mind, I don't know, decides that they have to move the hive for some reason, and dozens of bee scouts get sent out to find a good spot. They all come back and they dance the location of where they think the hive should be. And all of the rest of the thousands of bees in the hive begin to dance along until eventually they're all dancing the same dance, and that means they've decided where to go. So this is a pretty sophisticated form of communication. It's also a pretty radical form of politics and decision making, which, if you look at our election process, seems to be highly, highly intelligent. Also, slime mold apparently has a lot of intelligence. It barely has a nervous system, but one of the most difficult problems in it's sort of a test case for computer systems is what sometimes gets called the traveling salesman problem. It's extremely complicated to figure out the shortest route between multiple locations if each location can only be visited once, right? And obviously for like supply chain reasons, a lot of people have poured a lot of energy into this. All right, so Greater Tokyo has what's acknowledged as the most extensive and one of the most efficient urban rail networks. And in 2010, researchers put oat flakes on a flat surface, and each oat flake represented a station in the Tokyo urban rail network. And then they put slime mold on the map or on the table. And within a few hours, the mold had begun to create a web of threads for distributing nutrients between the distant stations. And it reproduced exactly one of the most efficient engineering networks in the world. So here's on the left, you see the slime mold, and on the right, you see a map of the Tokyo network. Okay, that's amazing. And again, a kind of intelligence in organisms that barely have a nervous system. All right, I saw that at least a couple of the students in my Intro to Theology class are on this, and welcome. That I'm using a book this year by Megan O'Geeblin. The book is called God, Human, Animal, Machine. I heard about this book on the Ezra Klein podcast, and I was like, wow, that sounds cool. And the point of the book is that O'Geeblin is arguing that we think in metaphors. Our thinking is always shaped and enabled by metaphors, and that metaphors can boomerang in that when we stop thinking that they're metaphors and think that they're actual reality, they lock us into a certain way of thinking. So her argument here is, this is a quote, to discover the truth, it's necessary to work within the metaphors of our own time, which are for the most part technological. And O'Geeblin went to Moody Bible College in Chicago and knows her history of theology and philosophy very, very well, and is talking about folks like Max Tegmark, who are interested in consciousness and how consciousness is related to the human body and to intelligence. And O'Geeblin realizes these are all the same debates that happened, particularly in the Middle Ages, but throughout Christian history, about the soul and how the soul is embodied. But now we're talking about it using completely different metaphors, and we're ending up in the same sort of dead ends and mistakes. And so part of what she's trying to do is to push us to understand that when we talk about things like the human mind, that if we're using metaphors from technology, they really are metaphors, right? So here's just a schematic drawing of a computer. There's an input device, a central processing unit that has a memory unit, and an output device. Almost every computer in the world is set up this way. And we're it's become very common to us to talk about the human brain or the human mind as though it's a central processing unit and is doing us. And that then constrains us, O'Geeblin is arguing, into thinking about intelligence, which we think of as natural intelligence, not artificial intelligence, as a series of computations. But as I've been trying to sort of sketch out quickly, there's lots and lots of kinds of intelligence that don't fit that model. All right, so I am going to pause for a sec there before I get into a little bit of the details around AI and just see if, I don't know, Kat, has anybody thrown a question in the chat?
Not yet, though Michael has kindly reminded us all that there is a super fun hand-raising feature. I have to remember where it is on Zoom before I can suggest people use it. But down at the bottom of your screen, there should be an option to raise your hand. You may have to click more to be able to see it, but that is a super helpful way to let us know you have a question.
Right. And I have a question, Michael, am I talking too fast?
No, I think you sound great with that. Thank you so much for asking.
Michael, when we got onto the Zoom, said it was like a nicer looking Joe Rogan.
I stand behind my words.
All right. All right. So I'm going to go ahead and talk about just some basics about how AI works, right? So every AI system is just it's which we call a model, is made up of two things. There's an algorithm, and there's data that gets fed into the algorithm. An algorithm sounds complicated because it sounds like the word algebra, but an algorithm is just a system of, it's just a list of instructions. So a cake recipe is an algorithm. If you follow it and you don't put in the things in the wrong order, and you beat it for the right amount of time, and you put it in an oven at the right temperature, you will get a cake. That's all an algorithm is, a set of instructions. Data is in some ways for AI more important because data is where things start to get dicey. So we're used to thinking when people ask for data, and at Iliff, like everywhere else, we're talking about making data-driven decisions, by which we mean we want what we do to match up with facts about the world. But data are not facts, right? Data are abstractions that somehow we choose and we hope that they represent a fact, right? So a famous example, which is quite relevant from AI, is a lot of police departments use predictive software to try to deploy police officers to high crime areas, right? But we don't actually know where a crime is going to be committed, right? So the proxy, the data that police departments use is arrest rates. So if a certain part of a city has a high arrest rate, the police will make the assumption or the correlation that there's more crime there, and they'll send more police there. But of course, that's a feedback loop, because the more police you send to a certain area, the more arrests there are going to be, right? So then the question always is the data, who picked the data? What's their agenda? And does the data adequately represent the real facts about the world that we're trying to find? And oftentimes it does not, which is a problem we can talk about. All right, so now I just want to talk about different kinds of AI, and the first kind I want to talk about is what sometimes is called good old-fashioned AI, which is kind of what I thought was boring in college, where you just learn a series of commands that you give to a computer to make it execute certain actions, right? And the famous, this is just an example of a command from the language Python, which is a very popular computer programming language, and the sort of the almost now ritualized practice in computer coding is that as you're learning a language, the first thing you tell the computer to do is you write the code for the computer to print out "Hello World." So that's the code in Python for "Hello World." So this form of AI is like symbolic logic or like mathematics, right? It's or a cake recipe. There's a very specific series of steps. You have to get each step exactly right. The computer is actually not that smart, and if you misspell a word, if I see a misspelled word, I almost always know what the word is supposed to be, and I just keep going. The computer will give you an error message, right? So everything has to be exactly logically in order for this kind of AI to work. Now, I'm going to talk a little bit about Demis Hassabis, not because I could have picked a number of people. He's sort of one of there's a cult of the founder in Silicon Valley, and he's one of I don't want to call him a cult leader because I'm not sure he wants to be, but people look at him as though he is, right? So I'm just going to use him as an example for each of the kinds of AI I'm going to talk about, because it turns out that he was doing something important at each of these phases. Right. So when he was 17, Hassabis dropped out of school. He was a very gifted mathematician and programmer, and working with a couple of adults, he was the designer and main programmer for an online game, a video game called Theme Park, which I had never played. By 1994, I was kind of out of the video game business. But it's one of the first big, super popular games where, there's a park on your screen, and you make decisions about which rides to have and how much do you spend keeping them up, and how much do you spend on, concessions and staff, and you win the game by having a financially successful theme park. A cake recipe. It's all a cake recipe. Every time you put in, it's like, let's say I want to have a Ferris wheel, the computer executes the same part of code always for that one request. It's a complicated code, but Hasabi's had to think of and code every single action that could happen in this game. Okay, so very powerful once it's set up. Can do millions of people enjoyed playing this game. It's kind of brittle in the sense that if you ask it to do something at all out of the ordinary, it won't understand you, and it's tedious to set up. Although, if it can process so much information so quickly that sometimes it's worth it, like it was with this game. Okay, the most maybe memorable achievement of this form of old-fashioned AI, which is also sometimes called symbolic AI, just because you have to type the symbols, the letters, the code to make it happen, is 1997, where IBM created a program, a model called Deep Blue, that beat the reigning world chess champion Garry Kasparov in a series of games of chess. And at this point, I remember this vividly because I used to kind of it's another life, but I used to kind of follow chess. And I remember thinking, and I think I shared this with a lot of people in the world, like, oh, something significant just happened. Like a machine, chess has been seen as a sign of intelligence, and the fact that a machine beat the best chess player in the world seemed highly significant. It turns out the AI is really good at doing things that humans are bad at, like chess. And it's really bad at doing things that humans are good at. So a 3-year-old is better at carrying a glass of water than an AI-controlled robot, right? We still are struggling to create a safe self-driving car, but I think most of us in the last few days have driven a car, and we do it very easily, and there's no problem, right? So again, back to my point, there's all kinds of intelligence, and machines that can play chess can't do some of the things that we do quite easily. All right, I just want to talk about Space Invaders because this was the last video game I was good at. I spent a ridiculous number of hours in the wee hours of the morning at a diner on Route 1 with my friends playing Space Invaders. In 2010, Demis Hassabis founded DeepMind, which was then bought by Google later, and he programmed it to play not a single game like he had with Theme Park, but he programmed it so that it could start learning how to play games, and it learned how to play all of the Atari games like Pong, Breakout, and Space Invaders, and pretty quickly, it could play these better even than me, even though I was like a Space Invaders guru. So we'll do, now the next phase of AI I want to talk about is how is that possible? How does the machine learn how to do something instead of being told explicitly how to do it, right? And just for no reason whatsoever, except I got to go there a few years ago. This is Paris. There's a street artist who installs murals. There's like 50 of these in Paris on street corners that are Space invaders. So I felt validated when I saw that. All right. So far, we've been talking about symbolic AI, or just telling it step by step exactly what to do. But it is possible now for machines to learn, and it's made AI even more powerful. And the reason, well, the way people figured this out was that they started trying to model computer programs on the human brain. So back to Demis Hassabis, in 2009, he went back to school and he got a PhD in cognitive neuroscience. And then he started building AI models that can learn, similar to the way that humans learn. So I want to talk a little bit about brains, neural networks, and artificial neural networks. So even without my saying it, you could tell these are two old Harvard professors. They were interested in how mammals see, and they did, I expect, a kind of a gruesome series of experiments, but nonetheless, I guess this is one of the advantages of theologians. We don't have to do gruesome experiments like this. They strapped down a cat and they put an electrode in the part of the cat's brain that was responsible for vision. And then they showed the cat a series of slides. And these are literally like slides from my childhood, like glass, two pieces of glass that you put an image between, and then you stick it under a lens that projects it onto a screen, right? And they showed it different slides, and they were going to measure the brain activity in the visual part of the visual cortex as the cat looked at different things, as a way of figuring out how do these sort of waves that hit a sensory organ and stimulate nerves, how does that get translated into an image, right? Okay. And this is one of those great sort of accidental discoveries of science. No matter what they showed the cat, nothing happened. They showed it, dogs, no. Cans of food, no. And then as they were changing the slides, just by accident, the edge of the glass slide is being pulled across the projection screen. And so a diagonal line moved across the screen, and the cat's visual cortex went nuts. So the brain starts firing. So that's interesting that a complete image didn't make it fire, but a diagonal line did. And so what they realized was that the way that vision works in mammals, and this is true for us as well, is that it's a series of neural layers, right? So on the left of the screen is the input layer, and it doesn't immediately get turned into an image. Each of the nerve endings in your retina pass along a certain amount of information, a certain level of energy that triggers an on-off switch. And the next layer, the first hidden layer, all it does is decide, is this a straight line or not? And then that information gets passed along to the next layer, who then decides, was it an angle or not? And then the next layer that decides, does it have a color or not? And there's hundreds and hundreds of these layers. And at the end of this whole process, there's the output layer, which is the image, right? So this is how all of our visual systems work. It's a very simplified schematic of a neural network. Here's a slightly more complex one. So when people talk about deep neural networks, they mean how many layers or how many layers of neurons are there. So this one has an input layer and then two, and then an output. But current deep neural networks can have thousands and thousands of these lines of neurons. And like a human brain, kind of, an artificial neuron, if the signal reaches a certain level, it just switches on, and if it doesn't reach that level, it switches off. Okay, and then that information is passed, it's combined with the rest in the layer, and it gets passed to the next neuron. It turns out human neurons are not just on-off switches. They do more complicated things, which is one reason why humans can still do things that computers can't. All right, so that's how vision works. So what you can do now is you can train a model. You can feed images. You can feed thousands and thousands of images to a model. Just show it pictures, for example, of cats and dogs. And you've labeled these pictures. So there's a lot of human labor involved in AI, by the way. It's often exploitative labor. And you just show it a picture and say cat or dog. And the algorithm, the machine, the model will make a guess, and it's going to get it wrong half the time. So you showed a picture of a dog and it says cat. And then you say, well, no, that was wrong. And now what happens is, through a process called backpropagation, which is just a mathematical formula, the machine goes back and adjusts the point at which each node gets triggered very slightly. And then it tries it again and it gets it wrong, and adjusts again and tries it again. And because you can feed it tens of thousands of images very quickly, because it runs at the speed of electricity, it only takes a couple of hours before the machine is starting to identify very, very accurately what's an image of a cat and what's an image of a dog. Okay, so this is actual machine learning. The machine is getting better to task, and it's not getting better because you're telling it what to do. I mean, you're telling it to say, is that a cat or a dog? But you don't actually know the adjustments that it's making to try to get the right answer. All right. And this is going to lead to what we call the black box problem. You feed a bunch of data, which we've already talked about, into an algorithm, and you've asked it, should so-and-so get a house loan? And it will give you an answer. And you cannot go into the algorithm, into these layers, and find exactly where the answer, what made it say no to this person, right? So if it starts giving you biased answers that a certain class of people gets no more often than you think it should, it's not always clear how to go in and fix the algorithm because it's trained itself. It's not been told what to do. All right. AI is great at classification, cats and dogs. It's great at prediction. You like that movie on Netflix? Try this one. Okay, in one of the early tests of this machine learning, this is important both because I like dogs, but also because it's an important concept to understand about how these models work. A group of researchers created a model and they taught it to distinguish, or it taught itself to distinguish between images of dogs and images of wolves. And on the left there is a dog. It happens to be a Greater Swiss Mountain Dog. I've had 3 of them. They're great, great dogs. And on the right's a wolf. And the computer model quickly learned to distinguish dogs and wolves as accurately as humans. In fact, sometimes I ask people to tell me if a picture is a wolf or a dog, and people are not that great at it, but the machine is better at it. Okay, then they discovered when I look at a picture and ask myself, is it a dog or a wolf? I'm looking at like, are the ears long and floppy? Is the tail thin or is the tail bushy? How long and skinny are the legs, right? I don't ask myself those explicit questions. I've just seen enough dogs and enough wolves to have the pattern in my mind that if it's got short pointy ears and it's furrier and the tail is bushy, it's a wolf, right? I know what a wolf looks like because I've been trained on millions of images, right? It turns out the computer model they created that was guessing so accurately was not actually looking at facial features or ears. It learned a shortcut. It taught itself a shortcut, and that shortcut was, is there snow? Because it turned out that the training data that they had trained it on, most of the pictures of wolves are wolves in snow, and most of the pictures of dogs are dogs not in snow. And then now next time you see a picture of your wolf, you'll be surprised how many times it's in snow, right? Okay, that's a great example of proxy data, right? So the machine found a pattern that the humans weren't thinking about. It did learn to make accurate predictions, but it's not actually the prediction that the human wanted, and it could lead to trouble if it was really important to know that this was a dog and the dog is standing in snow, right? So that's another reason why it's so important to know what data you're using to train a model and to have a group of people creating the model who are different from each other and see the world differently so that somebody among them says like, hey, by the way, has any of you guys noticed that there's always snow in the wolf pictures? Have any of you noticed that all the people getting rejected for this loan are from a specific zip code? That's not right. All right, so there's Demis Hassabis again. He gets his PhD in neuroscience. He's at DeepMind that gets bought by Google. He creates this model called AlphaGo, which Go is apparently, the thing about chess is complicated, but it's very constrained. There's 64 squares, 32 pieces. Each piece can only do a certain thing. And so although there's a lot of possibilities of what might happen, the possibilities are completely constrained by the rules of the game. Go, and I have not played Go, is apparently far more complicated, and it's so complicated. The patterns are there's so many more possible patterns that the world's best Go players have to play intuitively and not just memorize thousands and thousands of games that grandmasters have played before, right? And in 2016, using machine learning, now not like the IBM Deep Blue that had been programmed to play chess, AlphaGo fed thousands and thousands of it played itself thousands and thousands and thousands of times a game of Go, and was able to get so good at Go that it beat the world's Go champion. He'd actually been champion like 16 times in a very famous match in 2016 in South Korea. And immediately after that, the South Korean government invested like billions of dollars in artificial intelligence because they realized, oh, this is going to be a big deal. Okay, so there's real machine intelligence teaching itself, and the observers, like Go players who are observing, were like, this machine is doing things that seem crazy to us. No Go player would ever have made that choice, but it turned out to be super strategic. So somehow the machine found patterns and strategies that humans hadn't come up with yet. All right, so AI has a lot of great things about it. AlphaFold is another Demis Hassabis project at Google DeepMind. This is maybe one of the most exciting frontiers in AI research. And this, I'm now way out of my depth because I'm no kind of biologist, but it turns out we're all made up of a series of proteins. There's like 200 million kinds of proteins. And a protein is just a string of amino acids. There's 4 of them of different lengths and in different patterns that create all of these different building blocks of all life on Earth. And when you have a string of amino acids, it folds itself into a 3-dimensional shape. And it's the 3-dimensional shape that makes the proteins in your bodies able to do things like process visual signals and digest food and power your muscles that make you move. And so many diseases are caused by misfolding, which then gets replicated. And this is, for example, true of Alzheimer's and certain forms of dementia. Or your immune system often attacks invading viruses by finding a protein that has like the lock shape to the key of the virus and just surrounding it so it can't do any damage, right? It has taken in the past about 5 years of research to predict accurately how a single string of amino acids will fold. That used to get a PhD for doing one of them, and humans had figured out about 170,000 out of the 200 million. With the power of machine learning, AlphaFold has been able to start finding protein folding patterns at an astonishing rate. And this is, so for example, in the future, this is a picture of the coronavirus. It will be very quick to find a protein that will fit over the corona part of the virus that will keep it from inserting itself in your body and replicating. So there are going to be amazing advances in medicine for conditions and diseases that have been incurable or hard to cure. This is just going to accelerate phenomenally, which is great. All right. The last kind of AI I want to talk about is generative AI, which is all the buzz now. And it's a buzz because in 2020, OpenAI released ChatGPT. And we don't need to talk about what a transformer is, but that's what the T in GPT stands for. It's important to note that it's a powerful tool because it was trained on literally inconceivable amounts of data. And the data was obtained by creating web scraping bots that went through the entire web. And if you have a website, unless you have a specific code that tells a bot not to come onto it, and most sites do not have that, it was scraped by OpenAI. all the images, all the text were picked up and copied. Okay. And this was all used to train ChatGPT and the visual model that produced images, which was called DALL-E. And there's like 13 or 14 of these by different companies, but it's sort of an arms race to see whose is the best. But OpenAI always is in the news. Okay, there's a number of issues there about who the data belongs to. Was it okay for OpenAI to take it without telling people or getting their permission? The amount of computing power it takes to build a model this big and process that much data is a huge environmental toll. The amount of silicon and other precious minerals that have to be mined to make the chips are a huge environmental toll and are fueling a lot of these precious minerals are in places in the world where they fund conflict. And so like with diamonds, there's a real dark side to the AI industry. And there's copyright issues. Like a lot of the stuff that got scraped actually legally belongs to somebody. And there are now a lot of lawsuits by artists and comedians and writers, like the New York Times is suing OpenAI because OpenAI just scraped up the entire New York Times archive and now can produce articles that sound a lot like the New York Times, which is a threat to the New York Times financial survival. All right. Here's something that's problematic about these generative text models. And without going into the details too much, one of the reasons they're powerful is because they've been trained to associate words kind of the way that humans do. So these are called vector embeddings. It doesn't matter what they're called. But the same way that a human has a mental image of a relationship between the words man, woman, that's not the same, but correlated with their image between the words king and queen. Right? We don't have to, it creates cognitive shortcuts for us to understand what's signified by queen. It's a ruler, but it's a female ruler. A king is a ruler, but it's a male ruler, right? ChatGPT has been trained to associate words that have characteristics in common. So, for example, it knows it knows what the capitals of all the countries are, and it or has already associated Ankara with capital and the capital of Turkey. All right, that's great. But as we all know, human history and human language is exceedingly biased, and associational patterns have formed over time that are very destructive. And so it's a constant battle to prevent these complicated models, because they've been trained on this human data, from spitting out toxic, racist, misogynistic things. If you ask them, there's famous examples of people putting in queries about, you know, if this happens sometimes with autocorrect. If you start typing in your phone, I know a mathematician, it used to autocorrect it to he. Okay, that's not okay because that sends a message to girls that they can't be mathematicians. But the machine is simply replicating the patterns in human language that it's been trained on. And these machines just work. They're not actually producing language the way you do. They're just predicting the next most likely word. And because of human biases, sometimes the next most likely word is a word that we wish were not the most likely word. All right, so that becomes available in November 2022. This causes an explosion in interest in AI. I use ChatGPT a lot. It can save time. It can create a draft of something that doesn't have to be. It writes very clearly. It's very organized. It doesn't make grammatical errors. It doesn't sound like me. It doesn't sound like my students. It doesn't have a voice. It has a voice, but it has like a wooden voice. And for some things, it's more convenient than doing a Google search, because if I do a Google search and I say, like, where should I I'm going to travel to New York. Where should I eat? I'll get page after page of restaurant links that I then have to sort through and look at and decide. If I ask ChatGPT for a restaurant recommendation, it will curate a short list for me, especially if I put in my prompt like, I like steak, and I'm, this is, if I give it some parameters, it will tell me like 3 restaurants to look at, which is super useful and saves me a lot of time. So I asked ChatGPT, explain what generative AI is in 1 sentence in the style of the rapper Eminem. I take this as an example of kind of how cool this is and how powerful. I got generative AI is the game's new deity, crafting worlds with a code's creativity, spitting out art, texts, and beats, shaping the unseen with every keystroke it meets. Okay, that's pretty good. You can also, OpenAI has an image creator. If you type in a prompt, it will give you an image. I forgot to create an image. I was going to create an image for you of what a renewal session looked like, and I was going to ask it to do it in the style of certain artists. And the interesting thing is, for legal reasons, if you ask it to do it like Rembrandt, it will create an amazing image in less than a second of a bunch of us on a Zoom call in the style of Rembrandt. If you ask it to do it in the style of Jordan Castile, it won't do it because she's still alive and there's copyright issues with using her art to train a model. You just get an error message. All right, so here's the things to be aware of if you're using ChatGPT, which I encourage you to do. I encourage my students to use it. It's got the same bias and training data as all the other AI, so it's going to give you biased answers. It's only been the most recent version, ChatGPT 4, has data up to April 2023. So if you ask it who won the Nuggets game in October 2024 or October 2023, it won't know. It'll make up something though, because it'll predict the next most likely word. It's probably Nuggets, because Nuggets are pretty good. So it gives you answers that sound authoritative, even though they're incorrect, which is called hallucinating in the world of AI. It's an enclosed system which predicts the next most likely word, but it's not always accurate. And it was trained, as we said, by scraping the entire web. And a legal issue which is currently the standard, where the courts stand right now is, if you create something using ChatGPT, a machine cannot own a copyright. So it does not belong to OpenAI. It does not belong to you, unless you could prove in court that you substantially altered it in a creative way, and then it does belong to you, right? Also, and this is super important, when you put a prompt into ChatGPT, that prompt then is taken by OpenAI and used to train the next model. It doesn't belong to you, it belongs to OpenAI. So you should not, for example, say, I am looking for a good retirement plan, and here's all my financial records. It might give you a great plan, but that data then becomes part of the next model, and it's not that hard for somebody, either by accident or on purpose, to say like, oh, hey, that was Ted Vial's Social Security number that just went by. All right, so here's a famous example. There's a lot of articles about Tesla's self-driving cars, and every time they actually turn out to be pretty safe, but every time they crash, there's a big news article because people like to read news articles about crashes, especially fatal crashes. And in every article about Tesla cars crashing, Elon Musk gets mentioned. So until recently, every time somebody finds one of these, OpenAI fixes it. But until recently, if you ask ChatGPT, is Elon Musk dead? It just starts generating the next most likely word in the sentence. And because there are so many articles about people dying in car crashes in which Elon Musk is mentioned, it would say, yes, Elon Musk is dead. Okay. That is only accurate in the sense that the words predicted are likely, but of course, Elon Musk is very much alive. All right, so I'm gonna we don't need to go through this in detail. I'm going to sort of speed through the next few slides because I have too many slides. I just want to point out in surveillance studies, all the data you put online, and we'll talk about this in a minute, is used for people to learn about you so they can, usually so they can sell you things, right? And in surveillance studies has made, I think, the very accurate and telling argument that our current computer systems are building on a system of record keeping and surveillance that was created on slave plantations as a way of managing human labor, right? And so you can go through the history of record keeping and data that has been kept about humans. A lot of it starts at that time. And computers now can do this more accurately and more quickly, but in part because of the history of the reasons why people use human data, many of the historical problems are still embedded in the processes. All right. Ada Lovelace was the first person to realize that computers could process not just numbers, but anything that could be represented by numbers, like a musical score. A machine could process and create new music. This picture is actually literally a picture of computers. So computer used to mean humans who perform calculations. And during World War II, when many of the men were off in different theaters fighting in the military, the computers used by the military and the intelligence services were mostly women. And there's now some famous movies about that. Alan Turing, who's famous as a code breaker on the Enigma code, is a mathematician and one of the first people to theorize how a machine could do computing. But literally, he was concerned about computing in the sense of mathematical calculations, and partly as a matter of military intelligence, was interested in computers that could replace human computers that could do it without any errors and do it faster. But notice now already the kind of intelligence he's thinking a computer is designed to have. It's designed to do calculations, mathematical calculations. Here's the summer conference where the phrase AI was coined. The goal was to mirror human intelligence. I actually think this is the wrong goal. I think what's interesting about AI is it is intelligent, and it's a different form of intelligence in the world than human intelligence. It's another form of diversity among the ranges of different kinds of intelligence in humans and slime and bees and other systems. This can add to the richness of intelligence in the world, but it's not like human intelligence, which is why I prefer the term machine learning. So people talk about AI in terms of a system of booms and winters, summers and winters. And the booms are always associated with a big hype about how powerful the systems are. And then there's a huge amount of investment by military, by investors, and then it's disappointing and we enter into a winter. I would say right now that we're currently in a summer, a boom, with generative AI and ChatGPT. And there's a lot of hype, which is driving an unbelievable amount of investment in artificial intelligence, right? So you get, on my Twitter feed, or I guess X feed now, I always get things like this constantly every day. We are in a do or die moment right now for organizations adopting AI. A do or die moment. Like if your organization isn't using AI, you're going to die, right? Mark Cuban, if you don't know AI, you're going to fail, period. End of history. I have a friend who set up a consulting business because companies, he's worked at Google for a long time. He's well known in the computer industry. Companies call him and say, we know we need AI. We just don't have any idea what application we would use it for. And so he's helping to steer them into what might be useful to them, or just figuring out like, hey, actually right now we don't need it. But there's this pressure to use it or you're going to fail, right? If you're not learning AI in 2024, you're falling behind. And here's my favorite. Al-Qaeda rebrands as AI-Qaeda, raising $1 billion. So sort of a common joke in the tech world that if you say you're using AI, investors will pour in. All right. What I want to end with is what you need to know in the future to be a data citizen. And data citizenship is one of the things we talk about at the Iliff AI Institute and in the Innovation Lab. There are certain basic things that we all are familiar with that belong to citizenship, which is responsibility for self-governance. It's a set of political practices. You have to educate yourself. You have to vote. You have to participate in the process. And it's a series of habits and knowledges that you gain in order to be able to be a good citizen. I believe that we are in a current context where data and AI is so prevalent shaping our lives that what it takes to be a good citizen in the 2020s also requires certain basic habits and skills related to data. So if you just think about how much data you generate in the world, when you bank, when you go online, when you play games, when you drive by a cell phone tower, it's estimated that each one of us has generated people have collected about 40,000 data points on each of us. It doesn't take much data to identify you as a specific human. So if you shop online, there are people who know your phone number, credit card details, and email address. Here's just a chart about different information you give away using different online or phone applications. I remember signing up for Facebook, I forget how long ago, maybe 10 years ago, and I was very naive. I was like, I live in Colorado, I grew up in New Jersey, I wanted to keep in touch with my high school buddies. And I was amazed because the motto when I started signing in was always free, always will be. And I was like, that is so cool because I'm cheap, I'm not going to pay for it, but this is really cool. What I didn't know then that I know now is that if you're not paying for a product, you are the product. I have over the last 10 years given to Mark Zuckerberg tens of thousands of dollars of valuable data worth that much money that he then repackages and sells to people who want to sell to me, influence me, manipulate me. Okay, there are amazingly, more than any other realm of human ethics I can think of right now, there's widespread agreement on what the ethical principles in good AI are. It's got to be fair. You have to know that you're using it and what it's doing to you. There has to be responsibility when it goes haywire. It has to protect your privacy. What's not agreed upon is how to implement these principles. And this is just, I would encourage you to Google this guy. He's a mathematician at Oxford who explains in this kind of entertaining video, which is only about a minute long, how if somebody knows your birth date, your gender, and your zip code, they can identify you as a specific individual. So it doesn't take much data. I mean, all of the websites you go to say like, we don't sell your data, we anonymize your data, but there are data aggregators or data brokers. This is a $60 billion business who take data from social media and from financial records and from public records and put it back together and sell it so that if somebody wants to know where you live and what your shopping patterns are and your web habits are and your credit rating is, they can certainly find it. All right, so there's a couple things you can do. You can use a private search window. You can clear out your cookies, your browser histories. I have a service called Incogni, which you can request data brokers remove you from their systems, but there are about 260 of these brokers in the US. They're in different states. The states have different laws, and you have to ask each one individually to remove your data. So I pay like $13 a month for Incogni to ask each of these companies monthly to remove me. And they're legally obligated to do it, but in the US, and this is something I hope changes, you have to opt out. You get included in data sets unless you ask to opt out. In Europe, they can't use your data unless you explicitly give permission to opt in. All right, there's just a few companies with enough resources to build these, which I think is a problem in terms of power dynamics. And also, there's many, many amazing things we could do for humanity with AI. All of these companies with the power to build the most cutting edge tools are doing it for purposes of commerce. They want to sell you things. And so all of the resources are being geared towards that instead of towards solving some of the problems that humans probably care about more than self-driving cars. Colorado has the first in the country AI Consumer Protections for Artificial Intelligence Act. It kicks in 2026. Anybody using AI is going to have to certify that it does not create algorithmic bias. And that's actually hard to do. But I'm happy to live in a state that thinks that's important. And just ending quickly on what AI, Iliff has sort of two related AI projects. One is the AI Institute. That's Dr. Butler, Philip Butler, the other Dr. Butler, who is an amazing AI researcher and theologian, who does things like build large language models that, unlike Siri and Alexa, are culture specific. So there's a Chicano model and a Black model. And he's built a mental health app that you can have on your phone that will interact with you in a voice which is not threatening to you. So that's amazing. And then we have in the Innovation Lab sort of a consulting set of services where we can come and audit your algorithms for bias and for transparency and for responsibility. Up to this point, we've been working with organizations that feel like they have a moral obligation to do this. In 2026, everybody will be legally obligated to do this. And we also can help governments or organizations set up risk management systems of governance, so that they can comply with Colorado's law. So that's it. I'm going to stop there. I talked a little longer than I wanted, and we can just talk.
Well, thank you, Ted, for an absolutely incredible amount of information. We have gotten some questions in the chat, so I want to start with Tracy. You are welcome to come off of mute, Tracy, if you would like to, or we can read it from the chat.
Sure,
Go
I'm
for it.
happy to. Hi, Dr. Vial. Thanks for this wonderful presentation.
Hey, Tracy.
I'm thinking about the binaries. So yes or no binaries in terms of training AI machine learning models. At what point, or is there a point that the machine goes beyond the binary to learn? And if so, what does that look like? And are we still kind of philosophizing about that point? Have we reached that point? What is it? What are the implications? I mean, we know the binary is a metaphor that, but if the machines are being trained on that binary, then it's reinforcing a false reality. And so what's the conversation like around that?
Yeah, no, that's a great question. I mean, the thing about the world is, this is why thinking about intelligence as computing and thinking about consciousness as information can only be a metaphor, because the world is analog, and computers are digital, right? And so when I signed up for Facebook, they ask you to identify your gender, and back in the day, they asked you if you're male or female. I think there's you have 42 choices now, right? Or maybe there's even more, but there's still binary. I mean, there's still choices. Like, you either fit one category or another category, and you have to put yourself into a box, right? Which is not how human gender works. So machines can become sophisticated, but the way that neural networks work, you always have to reach a certain threshold to trigger a neuron to fire. And so they will always have to be broken down into complicated binaries, but binaries. So one of the things that we're doing in the AI Institute, and that Philip Butler's doing, is building a face data set that can be used to check off-the-shelf models to see if they're biased. And they are biased, because there's more pictures of white dudes online. They can identify white men with high degrees of accuracy, but misidentify other genders and darker skin tones, which, when these systems get used in police work, replicates a lot of the policing problems we've seen in this country. So we're trying to create a database where we do not assign people genders or races. We ask them how they self-identify and build the categories from the ground up. That still has to get coded into a set of categories that the computer understands, but at least the categories are generated organically.
Mary, would you like to come off mute, or we can read your question from the chat?
No, I'll be glad to come off mute. Thank you. This was wonderful. This was so much fun. Thank you so much.
Thanks, Mary. It's good to see you.
I just loved it. I think I understand. It's just complicated. I was trying to understand. So when you're trying to get the machine to understand whether it's a dog or a wolf,
Mhm.
and it says it's a dog, but it's really a wolf, and a human can say, nope, you're wrong. It's a dog. It's a wolf, not a dog. When you take the human out of it, I don't understand how the machine continues to correct itself.
Yeah. Okay. So that's great. So this is this kind of model is called supervised learning because there do have to be humans involved, because when you feed it 10,000 pictures of a dog, you have to have already labeled that as a dog so that you can tell the machine if it's right or wrong, right? And although high tech looks like a sort of clean, it looks like a nice job to have, the majority of tech workers are in developing countries working in essentially sweatshops labeling images. And but the worst job is labeling dangerous or pornographic images. The machine's trying to learn what's acceptable and what's not, but some human somewhere has to look at pictures flashing in front of their face at a certain fast rate and labeling them okay or not okay. That takes a real psychic toll on the workers, and they're getting paid nothing, right? So yes, that's there is another form of learning, of machine learning, called unsupervised learning, where, for example, I'm working on a project like this with a set of texts. This woman, Rahel Farnhagen, who's got like 10,000 letters, and she uses language very interestingly. And I've got Vicky Bredesen is an amazing Iliff student who knows more about computers than I do, who's helping me feed these texts into a computer and just find. I'm not telling them what patterns to find. I'm just saying, like, group the ways that she uses syntax into certain ways that you find, and then it's up to me to come and understand what the categories are.
Okay, thanks.
Oh. Quick note from Brother Daniel that he is fascinated and is going to go do some research on slime mold.
All right, that sounds like a Brother Daniel thing to do.
Inspiring project. Other questions?
Ah, Sandy.
Right.
So I think that let me make sure I see the full question. Yeah, okay, thanks, Sandy. Sandy's asking about using ChatGPT in teaching. So at Iliff, we have decided that's up to the individual professor, and the professor has to have an explicit statement in their syllabus, which now, since Tracy's in this Zoom call, I'm recognizing I forgot to do this quarter. Some people ban it as though it's just plagiarism. My personal opinion is that it's a tool, and that we're working with folks who are going to have this tool or tools like it in the future, and that part of our job is to help them use the tool as well as we can, the way they use all research and writing and theological tools. So I, in the past, have sometimes even required the use of ChatGPT. I've had students give it a draft of a paper, and then they ask ChatGPT to edit it for them, and then they have to tell me which edits they found helpful and which they didn't. Number one, that they get a better paper out of it, but number two, it's actually a thinking partner in the writing process. It's still the case that if you just have ChatGPT generate a paper, I will almost certainly know it because it doesn't sound like you. It sounds so. I mean, sometimes it writes with fewer errors than students, but oftentimes it just sounds dull, and our students are not dull. But I think I encourage teachers, all teachers at all levels from kindergarten on up, to play with it and to use it and to teach their students how to use it, or work with their students. Some of our students know how to use it better than me, to work with their students on using it well.
Before he begins his slime mold investigation, we have a question from Daniel.
Thanks, Kat. So yeah, I think it was last year, David Bentley Hart, who's one of my favorite theologians, wrote an article about artificial intelligence, and the article was titled "The Pool of Narcissus." And so his argument was sort of against this sort of science fiction generated apocalypse, right? That
Yeah.
AI was going to make us their slaves kind of thing. But it's interesting. He concludes the article with this image of Narcissus, right? Us gazing into something that is our own creation and falling in love with it. And just kind of wonder what you think about that. I think may be related to like bias, but his argument is basically like a computer can never become conscious or have its own mental process, but that the danger is about human formation, right? That if we act as it does, and it is getting more and more sophisticated, right? Like you can have avatars that look just like real people. I know,
Yeah.
in admissions AI. But that could be the possible danger, right? That it's treated that way. So just kind of
Yeah.
wondered if you had any thoughts or comments on that in the work you've done or research.
No, that's
Thanks.
great. Thanks. So there's like you stuck about 20 questions in there. But so so AI right now is a giant mirror, and it's reflecting back to us all of our biases, all of our intelligences. And it's a technical problem which AI will have to confront very soon, because as these large language models get trained on everything on the web, right now, more and more things that people put on the web are being generated by AI, right? I type up something, I ask ChatGPT to write something for me. I say, hey, I don't feel like responding to Daniel's email. You respond to it, and I send it, and then Google collects that, and it becomes part of their training set, right? There are beginning to be research published that shows that as the percentage of AI-generated text online grows, and as that AI-generated text is used to train the next AI model, the quality of text production begins to degenerate, right? It's literally inbreeding. So that's a real problem. So yes, it mirrors us back to ourselves. I worry less about the apocalypse. I actually think it's a dodge, and it may even be an intentional strategy by folks in Silicon Valley to distract us from the real issues. And the real issues are, what is it doing now when it's making credit decisions and policing decisions? And if we can implement the ethical values that most of us agree on in our current systems, as AI develops, it will not develop into an overlord. It will develop, but the idea that we should worry about what's going to happen. The other thing, as a scholar of religion, there's this really amazing scholar. He just went, I think, to Knox College. He was at Manhattan College, Robert Garassi, who does comparative studies in the US and in India about the way that people talk about technology and how it reflects their religious histories. So in the Christian West, people are premillennialists or postmillennialists, right? They're either everything's getting better or everything's getting worse. And that's how we talk about AI. It's going to solve all our problems, or it's going to enslave us. In India, traditionally, there's a more cyclical view of history, and people, when they imagine the future of AI, they imagine it going in these cycles. So that's a plug, I guess, for more scholars of religion in the field.
Right. No, that's awesome. Thanks so much.
We have a question from Sheila. Sheila, you are welcome to come off mute, or I can just share it from the chat.
I can just, what did I say? Who are the AI police? I think you probably answered much of that, but right now, who's watching?
What a
Crazy question, but yeah.
No, it's a great question. It depends where you live. In Europe, there is a highly developed regulatory system. In the US, until very recently, it's just been the Wild West, and unsurprisingly, it's been abused in the West because nobody has been watching. The Biden White House about 18 months ago put out a set of guidelines that were at first voluntary, but now they're establishing mandatory guidelines for the development of AI. Bills in California. Colorado has the first, I think, sort of comprehensive policy around making sure that your AI algorithms are not dangerously biased. Yes, the Algorithmic Justice League. Thank you. Okay, if you do one thing in the next couple of days, go to Netflix and watch Coded Bias, which is this amazing documentary about Joy Abulwimni, who was a PhD student at MIT. She wanted to build games, and she started realizing how biased the systems were. And she's founded this thing called the Algorithmic Justice League, which lobbies and teaches around the ways that bias show up in AI and things that we can do about it. So thanks, Phil. That's a great suggestion.
Okay. And the reason I asked is I actually watched a documentary on the fellow that developed AI. I forgot his name. And they asked him, do you think that AI at one point is going to bypass human control and run itself or fix itself? And he actually answered, yes, I do. He says that's one of the things I regret about, developing AI is that there is no end to it. And I personally do not believe that, but it was just interesting that the creator said that.
Yeah. I think you're talking about Jeffrey Hinton, who yeah.
Yes, that's who it is.
Yeah,
Yep.
Yeah. So I have to admit that I have a little bit of there's a game people play in Silicon Valley where if you listen to a podcast and they're interviewing somebody in the AI field, they'll ask them their PDOOM number. PDOOM is the odds that they think AI will wipe out humanity. And the folks who are building this stuff are like, yeah, my PDOOM number's around 10. It's 10% chance or 50% chance. And I'm like, this is crazy that you that you're doing that if this is really what you think. And I do actually wonder if it's a ploy to scare people because fear drives funding.
Yes.
In a way. So yes, I think if we can get a handle on transparency and bias now, and there are ways to do it, we'll have to worry less in the future about AI getting out of control.
Okay, thank you.
Right, we're going to round out with one final question, which is from Phil.
This has been awesome. Thank you so much for this conversation. And I would just I love the slime mold example, and I just wondered if you had other examples of biomimicry being used to inspire technology, especially specifically in the AI field, and if you had any recommendations or places to go to explore more of that.
That's a great question. I mean, the biggest biomimicry is neuroscience. And there are models that people are trying to build models that are self-evolving so that they the better a model does at a task, the more it reproduces itself. I know there are other, so the sort of biocomputing field is huge. And I would have to poke around to find great examples because that's not something I have at my fingertips, but it's super interesting.
Right. Fantastic. I love coming away from a session feeling like I both know a whole lot more and I have so much more that I want to learn about. So thank you, Dr. Vial, so much for an informative and thought-provoking conversation that I think could go on, but it is almost 1:30, so I want to wrap us up. Thank you all for joining, for kicking off this season with us. It is wonderful to have you here. I'm going to drop into the chat a link to that survey just to give us some quick thoughts on what you liked, what you think we can do better, and what you think we can do in the future. If you don't have time right now, totally fine. This link will also come in the email that's going to come to you in a couple of days with the session recording, as well as a link for our next session, So in October, we are talking about the future of democracy. That's going to be an incredible panel discussion and moderated by Dr. Amanda Henderson. So very excited for that. You'll see that registration link coming to you in your email as well. And I'm just going to throw out a quick plug. If you're excited about the stuff that Dr. Vial and the Innovation Lab team are doing, they are actually launching a whole new and exciting thing in kind of a different vein that's coming towards you today, and that is their Death Doula Certificate program. So more information coming your way via email about that, but another super cool program in a very relevant and exciting area. Thank you again for joining. Thank you for being part of the Iliff community and part of our conversations, and for helping us learn together. And I hope you all have a wonderful rest of your Wednesday. We'll see you next time.